All right. So, welcome, guys. Good evening. At least it's evening where I am today, and whatever time it is, you'll be watching this video from, as we're streaming live, and greetings, generally. So, this is a continuation of our classes that we've been having for 8 weeks thereabout. We've been talking about intermediate. We're covering intermediate modules on backend development using NodeJS. We've talked about a lot of things, and if you go over all the series in our YouTube channel, you'll be able to find modules that we've covered earlier. So today we'll be talking about a very important aspect of development, and it's called test-driven development. We'll be talking about test-driven development, how we can do tests, technologies we can use for testing, cool stuff. Yeah, so my name is Prosper. This is my first time anchoring the course. I've been a little bit more on the background. I'm sure you've heard my name by Benjamin, who's the usual voice you hear from these classes. So yeah, my name is Prosper, and like I said, I am doing this with Benjamin Ifinudu, who's a full stack developer with the main stack and the .NET framework here. So Prosper is a backend developer. I work with Node.js, MongoDB, TypeScript, and Express. All right, so let's just dive into test-driven development. So testing is a very important aspect of development, like I've pointed out. So we write codes that are supposed to perform in a certain kind of way, and then we have to be able to ascertain that these codes actually perform in those ways that we want it. So there'll be bugs here and there, and we have to make sure that we're able to reduce those bugs to a very bare minimum. And if it's even possible, we'll make them totally bug-free. All right, so one very important way to achieve this is by testing extensively the codes that we've written. It's very important that we test what we've written. And so the concept test-driven development points to it's a series of techniques that involve testing our codes and making sure that they are very, very performant. They are high performance, and then they can perform across even various devices and different operating systems. Yeah. So one other concept that is also used in with test-driven development is behavior-driven development. So it's just a concept that implies that we write our test cases first. We come up with a test suite, write those test cases, and then before we start programming. So we write those test cases, and then before we actually start building the application. So during the process of building the application, of course, a lot of things will break in the first place because we're trying to fulfill those test cases. We'll make sure that those test cases pass. That is the concept of behavior-driven development. So we're writing our codes to certify that those test cases pass, and then when we're done, we can go back and then refactor the codes into a more highly performant state, and also to make them more readable. So the behavior-driven development also gives rise to another concept known as the red-green refractor. Now, red-green refractor is also just like behavior-driven development, is a term under behavior-driven development. So what that means is that when you write your test cases, the you write your test cases before you start building the application. And so when you run that application against the test cases, they will fail at that first instance because you've not actually written the functions that the application will perform on, but you've only written the test. So that is the concept of red. So red is for your test cases failing, and then you begin to take those the minute instances of your test cases, and you begin to write your codes to fulfill the easiest of those instances to the hardest, right? And then your test cases begin to pass. So it moves from red to green. And then when you're done and all the test cases pass, you can now go back and refactor the code for it to be highly performant. Start considering things like time and readability of your code, and also reusability of your code, right? So that's red, green refactor. Red in the sense that you write your test cases before building your application, and then when you actually start building the application and run your application against the test cases, they fail in that first instance. They fail in that first instance. Yeah, pardon the noise. Yeah, so they fail in that first instance, but subsequently, as you begin to write your test so that the pass begins to turn to green here. So you have a green pass mark, so indicating that your test cases are fulfilling. After you've been able to pass all your test cases, then you now go back to refactor. So that's the concept red, green refactor. So behavior-driven development, just like test-driven development, is about creating a structure for your entire application. You're creating a structure, you're writing the functions, test cases for the functions that application will actually be built upon. And then when you're ready, you now go on and build the actual code using those test cases as a guide. Now, what that does is that it makes it easier for you to know that the goal you are trying to achieve is actually being achieved, because you can go ahead and start building the application without all of those testing, and then when you're done, you now start to do all of that testing. But that is quite problematic, and it's not really efficient, because that's when you now start finding that, okay, there's a fault somewhere, something is breaking somewhere. But if you had written those test cases beforehand, before you actually started building that application, once you are able to, pass all of those test cases, you know that, yeah, you're done with that project, because you passed all the test cases. And it is very robust in the sense that each test you write only account for a minute part of that of that application, the concept known as unit testing that we'll also talk about, right? So I would show you now some we'll try to create some sort of an analogy and see the difference between manual testing and automated testing, and see how the sort of problems that testing manually would portray. Yeah. So manual testing is what people are used to. Most people, it's convenient, right? But that's not really an efficient way of getting things done. So you test your functions, you test in the case of a whole API. Now you test your APIs and to see if they actually perform the way you want it to perform. And then you're doing all of those testing yourself. You're using the logs to your console, logging things here and there. You're trying to see values of variables, how functions resolve, and all of those. So they are not, the results you get are not very informative, in the sense that they are not clear. They might not point to a particular the particular place you're getting the issue from. Even you would know that if with experience in development, you would find that sometimes you would write a code, you write a piece of function, and then when you try to run it, you do not get that exact output that you desire, but it doesn't throw any error. So it is a valid way of writing that code, writing that function, but there's an error somewhere. So those are the kind of things you can be able to catch with automated testing. But with manual testing, you have to start figuring out where this is breaking out from, and using console logs that ends up littering your code. All right. So, but with automated testing, getting your results, and it's a very informative way. So they get displayed in a very informative way. It tells you where it is passing from, and in case where it's breaking, it also tells you where it's breaking. All right. So let's hope you can see my screen, guys. Hello, guys. Can you see my screen?
Yes. Now we can. Yes. Before it was just casual.
Oh,
we're good now.
Oh, okay. So you can see my VS Code here.
Yes, all yes, right. We can VS Code.
Oh, okay. So I'm going to. So I've written a function. So we'll take a look at this function. We'll take a look at this function, and then we'll see if by mere looking at it, it looks like it has any issue. All right. So first of all, let's take it step by step. All right. So this is a function called names of people. So the function names of people is supposed to collect an array of people, and then return the name of each person, right? So everything looks good. Everything looks good here on. And if you look at it by mere looking at it, it looks like it's valid JavaScript. So I'm going to run it and see if that's actually the case. We'll see if that's actually the case. Yeah. So I'm in the utils folder now where my function is sitting at. So I'm going to run that node index.js. Right. So you would see that there's no error emitting, right? So that also tells us that, yeah, it points to the fact that this is actually valid JavaScript. JavaScript says this as valid, right? So if we begin to now start to passing informations, like say we're passing an array, an actual array now into that function, and then we'll also pass the function and the array to this named variable. So the function again is supposed to take an array of people, and I have an array of people here, and then we expect it to iterate through the array of people and return the name of each person in the array. So everything looks good from here, right? So if we try to run this code again, we would see that again there is no issue. Everything looks good. So if we've now passed in the people array into this function, and then passing the names of people. So whatever this resolves is supposed to be stored inside this variable, and then over here we are logging the name of the variable. We are logging the variable, sorry. So if we run this again, we're not getting undefined, but we did pass names of people to the we did pass names, actual names of individuals to the names of people function, right? So we expect that when we console the log names, we're supposed to find say John, Jeremy, and Susan logged on our console, but that's not the case. We're getting undefined, right? Which is obviously due to something we've not done. But you can see that just by trying to test this function manually, this is the function that we're trying to test manually, this names of people function. Just by trying to test this function manually, we've had to create another array. We created an array of people that will pass as data to it, and then we'll also passed in the value of the names of people function into this named variable. And then we also have another console.log here, and you see how bulky that can get. So if you would have to do this for all of the functions that you have, it now becomes a problem. And even after doing all of these things, we still do not know why we are getting undefined. Now, this error, like I said before, that the error is not, we're not having the correct outcome, but we don't have an actual reason. So it now proves to the fact that the results are not displayed in a very informative way. Now we're getting undefined in all the places where we should get actual names, but there is no error thrown, and then we'll still have to rack our brains around to try to get to where the issue is coming from. All right. So, but in a case of automated testing, we would see that this thing is pointing to, it will point to the particular direction where the issue is coming from, and then we can take a look at it. So I have written a sort of test. Don't worry, you might not understand and stuffs just yet, but we'll get to looking at everything and knowing how they work. All right, so we're going to run this now with in an automated way and see the difference. Right, we run this in an automated way and see the difference. All right, so it is telling us that I've written 3 test cases now in my test suite. As I'm saying, first name should be John. First name must be a string. Oh, okay. I think I should turn part of it off. All right. Let me turn this part off. All right. So we have written from the look of just by looking at it now, this same thing that we ran using our usual way of manual testing that did not give any error. We are now we've now run it with a testing suite, and then we're seeing some sort of error. All right, so we wanted over here now, we said first name should be John. So and we're now getting a well-defined error that is telling us that it's expected the first name, which is the value of that function, to be John, but it didn't get that. And then it is getting undefined. You see from where I'm highlighting now, it is getting undefined, but that should actually be a name. So it's also, if you look at this, it's also telling us where the issue might be coming from, right? It's also telling us where the issue might be coming from. So this is index.test.js, which also is a pointer to the function that I exported from here. This function, right? So it is now that we've turned off a part of that function, we can run the test. We have two test cases now. To be called John. Then we also want that first name must be a string. All right. So we now know that our function is problematic, and then the difference between the manual way of testing now is that we did not actually get a very robust result from that, from our we didn't even get any error at all. We just got that our output is undefined. We got a problematic output, not the actual output that we had in mind to get. But in the case of the automated testing, we are getting error, and also a pointer to where those errors might be coming from. So if we look at this function again, you will find that we are returning the array of people, the iteration of the array of people, and then we are writing another. In the callback, we are not actually returning anything. We're just saying person.name. So there should be a return statement here, which we should actually return the names of each person within this array of people. So if we run the test again, they should both pass. All right. More than okay. So all our test cases are now passing because we fixed our function. All right. So you can see that with this, if you use these names of people in many places within your code, these names of people function in many places within your code, all you need to do is to just write a test case and test that function without even having to manually test it within the code. And then you would not even, let's say this under this our folder now, let's say this is our the part of the folder that will go to production. You would not need all of this console.log statements and all of this manual way of testing that would now litter the code and possibly cause things to break in production. Yeah. So I'll just go over a few cons of manual testing. First, it is difficult to write effectively, just like we've seen here. But now we're now passing variables here and there, using variables that we do not actually need, just because we're trying to get to see how our function resolves. We're passing variables that we do not actually need. Also, it's problematic here, because if we imagine we'll have to do this for everywhere, we need these names of people function, and say for other functions too, we'll have to pass in data and then without actually expecting without actually using the input from the users that will use that the project. So it becomes problematic, and then it impacts the actual problem. It's very hard to read. Now, if you look at this, you can already tell how hard it will be to read if this application becomes a very bulky one. All right, and also it's only a temporary fix. So for the pros of automated testing, now results are displayed in a very informative way. If we look at our console now, when our test cases were not passing, when our test cases were not passing, you can see that the results are displayed in an informative way. It's telling us where our issues are coming from, pointing to the part where our issues are coming from, and also when our test cases passed, everything was displayed in a very nice and a good way to read, nicely formatted, and yeah. So the test files can be separate from the real code. Now, if you look at what I have done here now, this is a representation of the. Let me bring this down. So this is a representation now of where the actual function lives. But if I remove all of these things now, which are things that I do not even need, all of this all the way down to the console.log, which are things that I do not need, I can still run my test. I can still run my test, and my test cases are passing because I have separated the actual testing code from where the function that we're testing actually lives. So things do not get clogged, the application do not get bulky for no reason. Yeah. So this is where I'm doing all my testing in another folder called test. I've written all my test cases there, and then I'm testing it against the function that lives somewhere else. So that's one very important advantage of automated testing. You do not have to do your testing within the same folder, within the same file where you are writing the actual functions, right? Output is easy to read and understand, just like we've seen. And also, a very important thing is that it guarantees that your codes are working well. In the case of the concept I introduced earlier, behavior-driven development, you've written the test cases and you know that this is what you're trying to. It's just like a project manager or a product manager coming up with user stories for an application. And those user stories are a guide to all the work that everybody on the team would do. All right. So, and once those user stories have been fulfilled, you can say to a reasonable extent that you've been able to satisfy the purpose of that project. That is also the case within testing, automated testing in this case. So you've written the test cases as in behavior-driven development before you start writing your actual test. And then when you finish the functions and then you run them against the test cases and the paths, you can tell you can guarantee you that your code is working as expected, and so that when it even moves to more sophisticated testing procedures like in the QA, because I told you earlier that the testing is a very broad field, and people build an entire career on it. So you know that from your own end, you've been able, as the developer, as the backend developer, or they even do this in the on the front end. Yeah. So as you know that as the developer, you've been able to satisfy to a reasonable extent that your code is working as expected, and then when it gets to QA, it just breezes through them and it moves to production, because you have done your own background check, you've written automated testing to check that everything is working as expected. Now, also, if anything it's broken because maybe you moved the variable here, you misread the scope of a variable and all of that, you instantly get the result, because once you run that test, look at this now. Look at this now. If I lose this return statement now, I run my test again, I'll start getting the errors. It's instantly, you're instantly getting those issues that have arisen, maybe due to omission or an oversight in any case. All right. So that's that for sort of a brief difference between manual testing and automated testing. Trying to highlight some pros and cons that comes with testing manually and doing your testing in an automated format. All right. So we also have different types of tests. So we have been using terms like unit testing since we've been talking about writing tests in very, very small chunks. Right. So yeah, you could already tell that is a type of test. So we have types of tests like unit testing, we have integration testing, and end-to-end testing. Yeah. So unit testing is a test that is carried out on just a specific portion of that code, preferably just one function at a time. So these names of people is a function, is a function, and then you're carrying out the test on just this particular function. So if the function lives within a broader function, or say a class that is supposed to behave in a particular way, you're testing the smallest portion of that that function or that class to satisfy that this thing actually works as it should. So you're testing the very smallest part, the minute, the smallest part of that function to make sure everything is working as it should. All right. So that is unit testing. Unit testing, as name implies, unit, you're testing the smallest part of a function. So we could check that, you know, in this entire function, let's say this names of people becomes a very broad function. It will now become even problematic to test the entire function on its own, because this function could be resolving, it could be resolving, but a particular part of it can be broken without you knowing, and that is causing some sort of error, some sort of problems for you. So if you test that function to the littlest detail, right, of say this parameter, you want to make sure that this parameter returns as a string. You're trying to make sure that this parameter returns as a string. That is an example of a small aspect that you could test. So unit testing is testing the smallest aspect of functions. Everything is working. And so integration testing. Integration testing are, you run tests for functions that requires other functions to resolve. All right. So if your function, say your function is a large function that requires the output of other functions, in the case of say a callback or something, for it to resolve. Now you haven't tested with the unit style, the unit method of tested every small aspect of that individual function, Now you test the entire function where that function the function you tested would live. Let's say within this names of people function, now we have another function that is just supposed to, you know, maybe check that what the parameter we're receiving here is a string. All right. So we now begin to test that function on its own. We're testing that function, which is unit testing, the other function that will live here. Let's just say, for example, let's say we have another function here. Let's say let's call it another function here that will I'll probably just leave here. Does the function in this case now it does nothing here. So, but say this function now actually has to do something. Right now, this function has to do something, right? And then you run unit tests for this function. Let's just name it do something. Function do something here. We'll just call it function do something. So unit test is that test you will carry out on this function do something. So this function do something is required for the names of people to be able to resolve. So maybe you're requiring an action in this do something to complete before names of people will resolve. Right. So once you've done your unit testing for this one, so the test that you will carry, that you carry for this broader names of people function is what is known as integration testing. So from the name integration, you've integrated function do something into names of people, and so you carry out a test for the entire names of people function. I haven't tested every smallest aspect of this do something, right? So that is integration testing. So end-to-end testing. Now, end-to-end testing is like testing the entire application. Is also known as E2E for short. You see people throwing the term around a lot. So E2E testing, you just know it's end-to-end testing. So it's testing the entire application from every end. Yeah, you're testing how every function in the broader format, having written tests for very minute details, which in the case now is the unit testing, and also having written tests for those functions that that require other functions to resolve. In the case now known as integration testing. And then in end-to-end testing, you are testing the entire application to certify that it works the exact way that it should work. All right. So yeah, we'll talk about two concepts that exist within testing. So just like in the testing result now, for you to know that your tests are passing, right? We'll talk about two concepts, right? So, but I'd like to know, is there questions so far? Guys, if there's question, put your hand up. Request for the mic. Do we have question? If there's no question, give me a thumbs up in the chat box so we continue. All right, I can see no questions from Mandy. Is that the case for everybody else?
No, I actually have a question.
All right. So let's just continue. All right.
The index.test.js file.
Can you speak up a bit? I can barely hear you.
Okay, I said the index.test.js script. You didn't actually give a description of the functions that are there. Like you didn't explain.
No, we'll get to that. We'll build the script the entire testing from ground up.
Okay.
Yeah, we'll get to that. So I just said we should ignore that part now. We'll just try to explain how distinct manual testing is from automated testing. So we'll get to building the actual testing from ground up. Yeah. So before we get to all of that, I'd like to talk about two concepts within testing, right? They are known as to pass and to test to fail to pass. All right. So now to pass means that the actual behavior that you require your functions to behave would be the yardstick for that test case to pass. All right. So to try and get it to pass, right? So your function must behave in that exact way that you want it for it to for that test case to pass. But in the case of to fail to pass, you're now trying to see what happens when say in the case of a function where you're expecting an array, someone has sent an object, and then of course that function should not resolve. So in that case, the yardstick for that function to that test case, sorry, to pass would be that the function does not resolve. So if the function fails to work the way it should work for your test case to pass, right? So just it's quite straightforward. I'll go over it again. So to pass is that the function which you've written and the test case has to be in line, right? So your function actually has to behave the way you want it to behave for that test case to pass. But in the case of your test case to fail to pass, you are modeling it to see what happens when you get some, let's say, an error input or something. So the function do not behave the way it should. The function fails. That is the condition that you require for your test case to pass. All right. So we'll look at technologies that we could use for building, for writing tests. So we have packages from NPM as usual. So NPM is very, very resourceful and in helping programmers do stuff, right? So we'll look at technologies that we can use for writing testing, right? So we have test suites like Jest. We also have Mockhi. and then an accession library known as chai.
We can't see your screen.
You can't see my screen?
Yes.
Oh, sorry about that. Let me share again. Can you see now?
Yes, yes.
Oh, all right. So we have testing suits like Jest and Mocha, and then Chai, which is an accession library. All right. So for our course, for this training, we'll be making use of Mocha and Chai. All right. So we'll talk about Mocha and Chai. So let's just go over to npm. Can you see my browser?
Yes.
Yeah. Okay. Cool. That's nice. Okay. So we'll go over to Mocha. Just search for Mocha npm and see what Mocha is. All right. So okay. Let's see the documentation of Mocha. So Mocha is a feature-rich JavaScript test framework running on NodeJS and in the browser. So it makes asynchronous testing simple and fun. All right. So for the test that I wrote here, I did that with Mocha, and then I also use the accession library Chai to make my accessions. Right. So we also look at Chai npm. Also look at Chai. So Chai is an accession library. So you do all your accession there. So accession, that's where you define the conditions for your test. All right. So Chai is a BDD, TDD, behavior-driven development. So this term means behavior-driven development. This is test-driven development. A session library for Node and the browser that can delightfully pair with any JavaScript testing framework. So Chai is the session library, while Mocha is the testing framework that we'll be using. So like I also pointed out, there are other testing framework like Jest, right? So you can go over npm and look at Jest, but in our case, we're using Mocha and Chai. Mocha, the testing framework, and Chai as the accession library. All right. So let us build. Let's see how we can use our do testing from ground up, like I said we would. So yeah, I'm going to create another folder now, and we'll call it let's just call it class example. We'll just try to replicate exactly what we've done here somewhere else. All right. So now class example would let me see into the class example. Class example. Do you have any other? Okay. I need to go one step backwards. All right. So see into class example. Yeah. So within class example, I'll create a folder that I'll call util, where we'll write our function that we require to be tested. And yeah, so inside util, I'll create a new file and I'll call it, let's say, index dot JavaScript JS. All right. Just hope this is within utils. All right. Okay. So inside so within here, let me try to load this again so that we can see only that folder. Okay, right. Class example, I guess. Unit testing. Class example, yeah. So let's just open only this class example so we can. All right. So we have utils here, and within our utils, we have index store .js, where we'll be writing our function that will require to be tested. Yeah. And then, so I should know Mokai and Chai are npm libraries, and so to use npm, we would have to initialize npm. So I do npm init. I give it the y flag. I don't have to answer all of those questions. All right. Yeah. So also I'll now install Mokai. That bigger. So I'll install Mokai and Chai on the same line. So testing is only useful for you as a developer. So you do not require your testing to be published or on production. Yeah. So whatever thing you do for your testing should be as just useful for you, just to make sure your codes are working in your local development environment. And so every framework that we'll be using for testing should be saved as development dependencies. And so because they are not actually required in production. So I would give it my capital D flag, so that Mocha and Chai will be saved as development dependencies. All right. Oh, I hope that doesn't take long. All right. So while that is installing, so let's just go over the function that we're going to write to test. So we can replicate that same function that we had. Okay, I think I have it somewhere. Can replicate that same function that we had. The gather the names of people function. Let's try it again. So we can say const names of people const names of people, array of people as parameter, and then yeah, so we have the names of people function now. All right. So we need names of people function. We're now saying we're trying to iterate over the every name within the array of people, and then return the person's name. All right. So that's what we'll try to do. So we'll say, first of all, I have to return this too. And then also return person dot name. All right. Great. So we'll export our function now. We'll export module exports. We'll export our function. All right. So yeah, have our function now that just takes in an array of people and then returns the name of each person. All right, this is our function now. So now that we have Mokai and Chai installed, let's look at how we can set it up. So Mokai makes setting up Mokai is very easy. Yeah. So in our package.json, you could already you would have seen that there's always a test script that is predefined whenever you create the package.json file. So within this test script, we can call Mokai. We can just call Mokai to run our test. So one very important part of Mokai is that Mokai would run every test that is located within the test folder. Now we'll talk about that now. The Mokai requires that you put all your tests within the test folder. So a very good advantage of Mokai now. So imagine we're looking at abstracting things here into different files. So it's not even practical that you do all your testing in one file. So you can have different files for your testing. Say maybe just a test file for the names of people function, a test file that does testing for another function and all of that. And so if you try to say run all of those tests, it's now becomes, if you want to run them one after the other, it becomes problematic. Imagine you have over 20 files that require you to run. So you start running them one after the other, it becomes problematic. What Mokai does is that if you place everything within the test folder, it will run once you call the Mokai to run that test. It will run all the tests that it finds within that test folder. Now, one very important thing is that the folder must be in the root directory of your project, and it must be named test. All right. It must be named test. The folder must be named test, and it must be on top the root directory of your project. So we've set our scripts now to run with the Mokai testing framework, and then we have also within our created a folder where all our test cases would lie. Now, also that brings me to what is known as test suite, right? So all the files. Now, test suite is a term that is used differently, right? So test suite can mean tests that are related, right? The similarly related unit tests, or it could also mean all the tests for that particular project. So all the tests that would live within this folder can be known as the test suite, and also the test that you'd write for one particular that are similarly related to each other. Say we would see now where we try to do a describe that would hold various assertions of our testing, and then we'll now run them. And so those tests that are similarly related to each other, that maybe you're testing for a particular function, can also be known as a test suite. So I would use that term interchangeably. Yeah, so that would I could use it, and then it would mean that my test, it would mean the test that exists within this test folder, and also it would also mean tests that are interrelated. All right, so we'll create a folder now for and call it index.test.js. So it's also very important that you make your folder naming as descriptive as possible, just so that your code becomes reusable by people and also become easy to read. All right. Yeah. So now we have our one test file now within our test suite, and yeah, we can begin to start writing our test. So we're trying to test these names of people function against different assertions. Right. So we can go ahead now. So we would need the assertion library, like I pointed out. So the assertion library we're using in this case now is chai. All right. So we would import our chai equal to choir chai. Choir chai. Choir chai. Yeah. And so within the chai, within this chai module, there are various methods and like expect. So we just the structure with the structures chai. So it goes to chai. So within this chai, there are various methods like expect, should, request, and a whole lot, and some others here that you could find out when you go through the chai documentation. Yeah. So these are just various assertion styles. These are just various assertion styles. Let's look at the chai documentation. Let's look at the chai documentation. Hope my screen is visible, guys.
Yes.
Hello, guys. My screen is visible, yeah?
Yes.
Yeah.
Yeah,
right.
yeah.
So this is one assertion style, should. This is another one, expect, and this is another one, assert. Now, so these are the methods that chai provides for doing your assertion. So in our case, we'll be using expect. We're using expect more, right? So yeah, so let's just keep the one we'll use and lose the others we do not want to use for now. All right. All right. So with the structured chai, and then we've been able to pick the expect method from chai. All right. So we talked about test suits. So I'm going to use this our names of people function to do that testing, and then we'll be able to point out a similarly related unit test for that function that would now make up the test suit. All right. So to write a test suit, you start with the keyword describe. Keyword describe. So describe takes first a string where you can name your entire test suit, right? So let's just call it, I would say, example test. I'll call it whatever you like, example test. All right. So it also takes the callback. Takes a callback. All right. Takes a callback. Right. So this is like a title for your test suits. Now, if you, I don't know if okay, I'm not sure I'll still have that. But if you look at the other test that we wrote, the one I used to explain manual and automated testing, you will find that there's always a title name for all of those for the test. So this is how you give your test suit a title. Now, remember I said these test suits are similarly related unit tests. Unit tests, you're testing the smallest part of all of those of the functions. Yeah. So we've given this a name. Now, we'll also need to get, what we want to test. The function we want to actually test is called the names of people function. That's the test. That's the function we want to test. Try to say utils. Right. We have our names of people function. Right. So inside the names of people, inside the describe, we can now pass in the data that the names of people would take. So in our case now, the people array. Remember we said the names of people will take an array of people as its input data. All right. So an array of people is an array of objects. People is an array of objects rather. The John, let's just copy this. It's let's have three names there. John, Jordan, Jeremy. All right. Okay. And then we'll like we did before in our manual test, we can also pass in, let's call this person. Now we can pass in the value that will be returned from the names of people into another another variable known as the person now. This is our case now. All right. So we are all set as far what as far as setting up our function and giving it data. All right. So we can now begin to write our test. Now, we also have another keyword that you can now use to start placing every assertion, every point that you want to test against. So it is called the it keyword. Now, it also takes a name where you can, make you can name it and it becomes more descriptive. All right. Also takes a callback. So we can give it a name, say, okay, we will say, first off, we can now write one unit test. Now we can say person, let's say person should be an array. All right. Oh no. Let's say okay. Let's say person should be an array. Let's do that first. Person should be an array. We'll see if that works, and then say person should be an array. All right. And then, all right. So the it keyword now allows us to, pass in a description to our test case. So this is the first unit test that we want to write for this function, all right? And then we're saying the person, so the value of person should be an array. Well, let's say person should be a string, right? I think it should return a string. So person should be a string. So that meaning the data type that will exist within this person should be a string. All right. So that is one unit test that we've been able to draw out. And then how do we now test to see if that would be the case? We can now use our expect keyword, which is the assertion from chai, and say expect. You can say expect, and then we'll pass in what we're trying to test, which is the person. And then we can say to be a, and then say string. All right. So we're expecting person to be a string. The person in this case now is this. So we're expecting person to be a string. All right. So this is one unit test that we've been able to draw out. So this keywords and this to be and other things that are available are within the documentation. All right. So if you check the documentation, the official documentation of Shai, you would find these, they are known as chains. You will find every keyword as to what's possible. All right. So just to speeding things up, we'll just make use of this. All right. Okay, so we've written one unit test now. We're saying person should be a string. So let's see if that is the case now. Let's see if that is the case. So like you know, to run, now this is like key and value pairs here, and this is like the command, and this is the required output, which is the Mokai command that would run. So you can just do npm run test, npm test, and then it will pick this Mokai, and then with Mokai already configured and our test folder here that have been created in the root directory, and then our one file that contains our test suite now, which will just automatically read, and then we'll see if that passes. So let us see if that passes. npm test. Okay. Oh, okay. So now we said person should be a string, but what it's got is not a string. So we can already see that our test case failed. So person is not a string. So if we're saying we're expecting person to be a string and then person is not a string, immediately we run that test, we've been able to identify that the person is not a string. So we are getting our session is not being met. So person is not a string. So let's say in our case now, we didn't make this assertion as it should be. So which could not be the case of our function actually breaking. But if you look at how this error has been presented, you would appreciate what automated testing does for you. So it has pointed out that what it got is an array, but we've said we expected it to be a string. So in the case where we actually wanted it to be a string and then we got an array, we would already know that yes, our function is failing. So if we say we change this to be array, we change this to be array, We want it to be an array. For array, it is an. And let's see if our test case passes this time. All right. So we wanted we said person should be an array, and yeah, it's an array. So our test case passed. All right. So we can go ahead now, write another assertion and say, to write another assertion, we bring our its keyword again and put our description, what's to make our test results very informative. Write our callback. So in this case, we can say we want name of person to equal to be we want the first, let's say, first name should be John. So we want first name to be John. All right. So yeah, this is our second test that we want to test against. And we can say, bring our expect keyword again and say expect person. Now remember, there's a name object. There's an object with the name key and the value. And so we're saying expect person.name to equal first off to equal John. So if the person, the name is not John, okay, no. So it's an array here. So person returns an array. So we cannot reference it like that. So we're saying the first name in the array, let's say in the array, should be John. We were saying first name in the array should be John. So we can reference that because this person now, we already know that it's returns as an array. So we can point that with the bracket notation and call the one at index. So we're expecting the first one to be John. So if the first one is not John, our test case would not pass. All right. Let's run that again and see. All right, our test case is passing. So we're saying first name in the array should be John, and that is the case. All right. Again, we can write another unit test. Write another unit test and say, put our callback now. We can say last name should be okay. Should be, let's write one that will fail now. So last name should be Jeremy. Last name should be Jeremy. And then we say expect So we expect the last name to be Jeremy. So let's just make everything fast. So Jeremy should be at index 2. So to equal Jeremy. All right. Run that. So all our test cases are passing. So if we should come back now and remove something and break something here, say we remove this return statement from our utils function, from our function, our names of people function, and we run our test again. Now, we can see that only one of our test cases is passing, and that's the one that says the person should be an array. All right. So the rest that says first name in the array should be John, last name in the array should be Jeremy, and not filling. And then we can be able to tell the issue that is coming from it. So if you look at our session error, our test suite is already telling us that it expected something to equal John, but it got undefined. All right. And then it's showing you where the location of that error. So with this in mind, you can be able to tell that your code is already breaking instead of having to write them individually again. And then if you use this names of people function in many parts of the code, all you just need to do is do all your testing here. And if you need to even change and look for everywhere you use names of people to start changing the data points, you just need to change the data point from, because you're only putting the input from here. It works accordingly. So if we put our return statement back here and run our test again, everything is working. So this is our actual code that will go to production, and you can see here that there is no console.log anywhere. We're not using variables that we do not need anywhere, and we're not even passing values into the array anywhere in our code. This is clean, it's readable, and it's reusable. All right. So this is just like a brief overview of what's possible with testing. You can go over the Mocha and Chai libraries, look at the documentation, and see what you can do and what you cannot do here. Right. So I'd also have that testing is not only possible for just functions and all. You can test your APIs and stuff, right? So like we said, we talked about integration testing, and also this testing now is not just this way of testing. Mocha and Chai is not just useful for only functions, and all. We can also use them to test our APIs, and also we'll see examples of how we can test our APIs and see if they're actually working well. So that thing we go to Postman and do to say you send you input data, and then you try to run them and see if it works. You could just write test cases, and once you do your npm test, you would see if that data is actually submitting to that endpoint, if you're actually getting something written on the database, or you're actually getting something retrieved from the database. All right. So before we go into that, do we have questions? Can you guys see my screen? Saying your screen is blank.
Yeah, we can see your screen.
Oh, it was
we can
blank
see your
before.
screen. No, it wasn't blank. It's okay.
Okay. All right. So since there are no questions, let's just look at how we can test our APIs. And so I have because we don't have to go into creating new prod application and all of that. I have a prod application here already. All right. So if you look at my little prod application here, I have a product controller that you can create products with, you can get all products from, and you can get a single product, update a single product, delete a single product. Yeah. Also, I've also written so some sort of a test to show how that works. But let's do it from the scratch again. So we'll leave this one and we'll leave this one here, but we'll try to replicate this. Let's call it class test.js variable with naming. So just pardon me. All right. So yeah. So in this test we'll try to test this API that we've written, our routes here, to test our endpoints now to see if all the functions and every unit of say for a function like for a controller like get all products that have various functions within it, various things that needs to be done within it, and then we'll try to see if that actually works. All right, we'll see if that actually works without even having to go and use Postman and all of that for the testing. All right. So with this, we are able to beat time and stuff, because like in the case of behavioral driven development, you can actually start out your entire application by just by declaring your test cases before starting to even build your API. And so when you run your npm test, you see where it's breaking from, and then when you've been able to satisfy all of those of those errors, you now get an actual working application that you can say, okay, this is working as per my use case. All right. And yeah, let's just get into it. Let's get into it. Okay. So I already have let's look at my package of JSON. So I have my test folder set up here, and I've set the script as we did in the former one we just saw. And then if you look at my dependencies, look at my dev dependencies now. I have Chai, I have Mocha, I have NodeMon and all. I think they should be. Oh, okay. This should be. So this one is what I want you to look at. This Chai HTTP. This is an npm package. Let's see what npm says it does. So Chai HTTP npm. Yeah. So it's just a plugin you can use with Chai. Where's that documentation? The plugin you can use with Chai. Well, let's just we don't have time here. So it's a plugin you can use with Chai to send requests to endpoints and then get results and all of that. So it's called Chai HTTP. You install it just like you install every other dependency. So, well, I guess I missed the D flag here. So this should actually be in the dev dependencies, because like I said before, testing is just for development purposes, and it's not required upstream in the case of production. Yeah. So let us now try to test our endpoint. So we have our routes all set up. So to get all products, our route starts from here /API/ look into our router file for products. So /API/all is for get all products, and also everything is all set. So we'll just try to see how we can test that endpoint with our Mocha and Chai library. So yeah, we import our dependencies. So const try go to require try. Require try. So const try HTTP. Go to require try HTTP. Try HTTP. So it's a plugin. You just say try.use try HTTP. We just pass try HTTP to the try library, session library, and then like we did before, we can destructure try now, pick in the methods that we want expect, we want request, because we'll be using request and expect, getting them from try. Great. All right, so we're all set up as far importing dependencies. Yeah, so we'll begin to write our test suite now, describe. Then let's say API test, API test. I feel like I named it the same thing with the other one. All right, so callback. All right, so we need to, so this is a request that will be made to an endpoint, and so we need to spell out like at least the base URL of that endpoint, just so we don't make things look nasty. So we can since it will be running a localhost, we can say const host equal to localhost. I think it's 127.00.0.0. Let's just get that from here. Not sure. Let's get that from here. Okay. So yeah, this is the address for localhost, and then this is my port where my app is listening on, port 4000. Right. So this is host, and yeah, so we can begin to write our test now and say it's. So we write two test cases. First off, we write one that we pass to pass, and then one that we fail to pass. Right, just so we get the analogy and everything we're trying to say. So we say this one should fetch all products. This one should, our first assertion is that it should fetch all products. All right, so put our callback again. So we can say const response, as we know, is short for response. All right, so I need some data from here. I can't remember now. All right, so is somebody speaking? All right. Okay. Okay. So I'll make this an asynchronous function because we'd have to communicate with something outside our setup. All right. So I'll just explain it, right? So this is we're creating a variable known as response, and then this is what will actually do the call to this endpoint. All right. So our endpoint is host, which is we've passed the beginning of that, which is this is a local host address and the port my app is listening on, and then with the extension, so which equals to this. So from the point of our server / API / router, if you look at router, the one for get all is /all. Okay. Yeah. So /API /all, we're setting the content type to be application /JSON and all. All right. So we can now do our session. So how can we tell now if we actually got, say, a data from our request? First off, a successful request, say in the case of a GET request, should return the status code of 200, right? So if this is successful and it does return the status code of 200, we would know that this endpoint is actually fetching the products, right? So we can use that as our session. So we can expect that res to have status 200. So if this worked, okay, I guess this should come in here. So if this worked, res, which is our variable here that will return whatever response we got from calling this endpoint, we're expecting it to have a status code of 200. All right. So because this thing takes time, so we can set a timeout for it. But let's even run it without a timeout first, and then you'd see that we'll have some issues. All right, because it takes time to resolve, and the default timeout is not. Let me. Let's turn this one off because Smoker is going to also run this API.test.js. So I want everything to be clear. Let's say I even named it the same thing. All right. So let's try to run our test now. First off, we'll have to start our application because we're listening on localhost. We'll have to start our application and we'll say npm run dev. Then run dev. Then we can go to another instance of our terminal and run our test there, the npm test. All right. That even happened very fast, so we don't even need the timeout. So our test is passing. So our first test case is to pass. Let's put that here. So we're expecting this to pass. So to pass, meaning what we expect that it should fetch all products should actually happen for that test case to pass. So if we try to control the log response here, you would see that indeed, we actually got a response from calling that endpoint. So we'll run that test case again and see what happens. Okay. Timeout issues now. All right. Let's just set a timeout here. So timeout. Set it to like 20,000 milliseconds. All right, so but you can see that when it did actually resolve, we are getting data. So you can see that indeed we are getting a response from calling this endpoint. So if we lose that console.log and try to run our test again now, our test is actually passing. All right, so we are indeed getting a response. So our test is passing. So that's one for to pass. So we can also write another test that should pass to pass again before we write one that should fail to before it will pass. So we can say, let's copy this and swap things around. Let's copy this and swap this around. So we know that it returned 200. Yes, it returned 200, but there could be a case where we actually got the status code 200, but the actual data that we require did not really exist. All right, there's no data like the actual products that we require to fetch. All right, so we could write another test case that says response. So we're expecting the response. So the response should contain actual products data. So it should contain actual products data. So if I want to console.log this thing again so we can see the case of this one that is passing, and then we'll see how we can reference that data. So run npm test. All right. So it returns a very massive object here. It returns a very massive object, and then you can see various details about the request and then the response here. So it's in the array there's a key called text that contains the actual results that we got from the endpoint. So these are details of the endpoint. So we can test against that now and say let's clear this. Oh well, let's write our test first. So we can say we can expect res dot text, which is Chai's custom way of referencing data from it got from the request. So we can say we can expect res dot text to exist. All right. Let's console.log. Let's use this console to this. I'm just using this console.log to show you the information that we are getting from the request. All right. So in our actual testing, there's no need to write console.log statements anyway. So run our test again. Yeah. So our first test case, fetch all products. It did fetch all products. Fetch all products and expect it to have a status 200. Yeah, that passed. It had a status 200. Fetch all products, and then we expect to respond to contain actual product data. So we're testing against that with the custom way Chai references data from the request, which is text. We're saying the rest of the text to exist. and it did exist. All right, so this one now is another test that pass to pass. So let's write one more test that fails to pass, and then so let's write another test now. This one will fail to pass. So meaning we should get sort of right. So we can say in our description now, we can say it should not fetch product details, product data if the endpoint is wrong. So let's say somebody misses the endpoint. Let's say it's wrongly spelled. Let's just make that more wrongly spelled. So there's a mismatch in the endpoint. Let's say for some reason there is no all here. There's no in the all, there's someone misses the last all. So this would actually fail. So for no reason should we be able to fetch data from the endpoint if we do not get that actual do not get the actual endpoint correct. All right. So how do we assert that now? We can say, sorry for the formatting. Well, so we can say we expect res to have a status of 404, right? So if an endpoint, if somebody is trying to reach an endpoint that does not exist within your application, it will return a status of 404, yeah. So we're expecting res to have a status of 404, which is not found, because it's actually going to look through our entire setup, and it will not find an endpoint called API/all. So this test should fail for it to pass. So if we run it now, the socket hung up. Okay, so let's run that again. Let's see if our app is still running. Okay, the app has crashed here. Let's see what's the reason. Cast error, new cast error. So let's just run this app again and run our test again. Spelling here. Cast the object field for value. Oh, well, let's see. Okay, let's put an entirely different. I guess it's mistaking that endpoint for something else. Let's say /get here. We'll start that. Our server is already started again, and then we'll try to run it now. All right. So it should not fetch product data if the endpoint is wrongly spelled. So we are trying to route to an endpoint that does not exist within our system, and of course we'll get a 404 error. So we've stated that the status should be 404, and then that actually happened. That is why our test is passing. So that's in this case now, our test failed to pass. So our test case passed, but the actual result that we expected did not pass. Yeah. So that's it from me for now as per introduction to unit testing and test-driven development, behavior-driven development. Yeah. So let's have questions. I believe there will be questions. So let's have questions, guys. Questions.
Can you hear me?
Yeah. Kelechuku, go ahead.
Can you hear me?
Yes, Kelechuku, go ahead. I can hear you.
Okay. Are we actually going to test the actual endpoints directly before writing the test?
Who's speaking? Uzo, where you are is quite noisy. What are you trying to say?
I said, are we going to test the actual?
I didn't get that question. Maybe you can type it in the chat box.
Okay, hello. Can you hear me?
Yeah, I can hear you.
I said, are we actually going to test the API endpoint directly?
Yes, if you can. Yeah, go on.
And if, for instance, now we have requests that are going to persist in the database, are we going to test it?
If we have requests that are going to
kind of persist data.
I can barely hear you. Maybe just type in the chat box.
I think if we have requests that are going to persist data, are we going to test them directly from our test, or there's a way we are going to go around it? Like say a post request.
Okay. Okay. A post request. Yeah, we can also test a post request, right? That can, let's say we're trying to write to a database now. This is 9 o'clock already. Okay, well let's see if we can just run one test case for post request. All right, so I have. Let me just see. I'll just get that and then we'll explain it. Give me a few. I'll just stop sharing for a while. Okay. Yeah, so we can also test for in cases where we would need data to be written to the database. All right. So these are endpoints. Yeah. And if you're familiar with Axios and other clients that are used to send requests, you'd find that there are various ways that they handle all the type of requests, get, put, and delete, and the rest. So Chai also has a way that it handles requests that would require you adding data to the database. It has a way it does that. So I'm trying to get okay. Okay, it has a way it handles that. So I'm trying to get a quick in the case of, how do I have that? Can you guys hear me?
Yeah,
we
can.
Yes,
Oh, okay.
Yeah, we can hear you.
All right, yeah. Give me a few. Okay, yeah, I got it. Okay, so I'm going to grab this now. All right. So let me know when you can see my screen. Can you see my screen, guys?
Yeah, it's sharing now. We can see.
Yeah.
All right. Okay. So I have a new test now that says it should post a new user. Let's make this a new product. A new product. we post a new product, and we post a new product. Yeah. So the endpoint for posting a product would be, let's see that, follow router / API / okay, that's just slash. Okay. So we're writing a new assertion that says you should post a new product / API / yeah. So if you look at this now, this is the way we're sending. This is the endpoint, and this is the data that we'll be sending to that endpoint. So in our product schema, we have things like name, price, description, right, which are required. So we'll just try to model that. Name, say price, and description. All right. So
Yeah, I think those the user ID.
no, that's not required to. So just flag.
Yeah, okay. All right.
Yeah. Let's just say 1,200 and stuff. All right. So you should post a new product. Let's make this 20,000. So we've added a new test case now to this. I was saying we expect that for when you create a product, or you create an entry into the database, the status code will be 201, which is created. So we're expecting the status to be 201, which will tell us that here there's something that actually be written to the database. So let's try and run that test now. See. Should post a new code also. Okay, I'm getting. I expected to get 201, but I guess what I'm seeing is 401. Let me see how responded here. Okay. So expected objects events to have status code 201, but got 401. 401, which could be bad request. Let's see how we're sending our okay. Let's set the content type. See if that helps. Set the content type. All right, let's see if that helps. Let's clear this out. Still got 201. Price description. Yeah, slash. I'm not sure that's the endpoint. Well, there's no. We'll look over this and then I'll correct it and then maybe send it across to you guys. Well, so this is how you can send a post request to the as per testing with Chai. Yeah. So this is how you can send a post request as per testing with Chai. Then look over it and see where the issue is coming from. That's okay. I guess so. There's a middleware here. Why I should have known. Create product 401 is forbidden here. So middleware is actually blocking that. So it's a protected route. So yeah, let's run the test again and see. Got 500 this time. Got 500 this time.
I think to check the previous terminal if it's still running.
Okay. Yeah, it is.
Okay.
Name, price, description, content type. Course. See. That works. All right, let's not just waste much time on this. Otherwise, it's getting 500. Some sort of server error or something. Yeah, some sort of server error. Yeah, but if you look at this, this is how you send a push request to endpoints. So maybe I could swap that out with this. Let's see, slash let me swap that out with another endpoint and see if it's the same thing. Slash API slash user slash user slash okay. So slash API slash user API slash user, and then let's see what we're supposed to send from the user schema. Full name, email, and password. Full name, email, and password. Full name, email, password. Let's see if I have any. I guess I know what's a prosper at gmail.com. My controller. Maybe I have some sort of validation. That should be what's for throwing that error. Let's see. Let me just close any validation I may have. See? All right, so let's try on this. All right, so everything is passing. So yeah, you can see that it should post a new. Okay, I called it product, so let's change this to user. It should post a new user. You should post a new user, and then when we run that, it actually don't like a name change. You should post it.
I think you since like the validation for the email.
Yeah.
So
Yeah, exactly. So it's finding a duplicate email now. Exactly. Thanks, Ben. It's finding a duplicate email now, so we can, so you can already see that it's checking against actual data, and if we look at our, so yeah, it's still passing. So if we run this again, it already created that email. It already created this user inside the database, so that email will be taken, and from here I have my check that does that to see if email already exists and all. And if we run this, we should have that error again. All right. So yeah, I hope that answers your question. Uzo.
Yes. It actually does.
All right. Nice.
Thank you. I really appreciate it. Thank you.
Who else? Questions?
Okay, good evening.
Yeah.
Yeah, so my question is just a small syntax question. So I noticed after every it, you use only one except. Can we have multiple for one it?
Let's okay, go on.
Okay, and the second one was you said something about mocha, right? Running all the files in the test folder. So the API.test.js, the test you write there, is it just a convention? Or is it something more complex?
So
you write API.
This is the API.test.js, right? It's not a convention. This is the actual test now. This is the same test that we're trying to replicate here. So I turned it off so that we can be able to see these ones that we are writing here now. So I'm going to turn that on again, and then we'll see that Mocha does actually write, let's just say, API tests from class.
No, I'm talking about the file name, like class test, dot test we are writing after.
Okay, okay.
Yeah, is it a convention?
Yeah, so it's best to make, so I said that before we even start writing the actual test. So it's best you name your folders, your files as descriptive as possible. Since all of this here are not actual, they are not codes that the product actually works on. They're just for testing. So by convention, yeah, you should name them with the test, or you can also say underscore test.js. Yeah. So you asked another question. Sorry, I missed that.
Sorry, the except you use for it.
Okay, if we can have more than one expect. So yeah, so let's it's best we just, all right. So let's move this one. Let's see. Let's see if that happens. All right. And I always play this up. Run this test again. So the first test says it should fetch all product that passed. Second one, it should fetch all products. But now we do not know which of this assertion is actually the one making it to pass. So it's best, right, as per unit testing, it didn't throw anything to write one assertion for every unit of your test. So I don't think it's ran up to this point. Let's try and let's model this, so do something different and see if we'll say let it have status 400, and we'll also say at the same status 200, and at the same time we'll also say you have status another different status and see what happens. Have status 400. All right. So we should end this class by latest 9:25. So npm test, and let's see. All right. So we cannot use in operator to search for status. search uploader did not pass. Okay, so I guess it's also, we can have more than one express statement within each test, but for clarity, because we're trying to make our test as descriptive as possible, it's best we just have one assertion per every unit of the test we're trying to write, just so every test becomes descriptive. Because again, I was saying we're expecting it to fetch uploaders, and we know that the case for we to know that test passes, for it to have a status of 200. And then if we put another case here now, and if that does not resolve, we might not actually be able to pinpoint which of them is causing the issue. So it's best we have one assertion per test case. Is that fair enough?
Yes, thank you.
All right. Any other question? All right, guys. In absence of any other question, we'll call it a day. So maybe Ben has some few words to share with us. Right? So Ben, just let's have your thoughts, and that will be the end of the class. So thanks, guys. Yeah, see you next week.
Okay, thanks a very good lot, first of all, for standing in for me. I really appreciate that. And guys, thanks for also turning up for today's class. We've actually missed a couple of classes here today. We just had to stretch a little bit longer to cover up this part. So please go back to study this. This is a core aspect of being an intermediate to senior developer. You need to be able to have test-driven development as part of your skills, part of what you do. You don't just do things manually all the time, like Professor has mentioned. You need to also have test cases, and this will go a lot better. So for most jobs that are looking for intermediate to senior developers, they will require you to have test cases, okay, to have test written. So please go over the classes, go over the recordings, practice, and most of what we are giving you is just you could say an introduction. So there's so much that you will be able to understand if you understand the key concept. So we explain the key concept, introduce you to it, or you have to do your own personal study to cover up for that. So that will be that from us. We'll be having we'll be looking at deployment in the following week. Looking at deployment in the following week, working with Heroku. So you can also do well to prepare ahead of time. You can go do your studies. So we're looking at the deployment, and hopefully before the end of this program, we should be having one very key person teaching GraphQL. So also look forward to that. So I think that's that for today. I appreciate your time, and once again, Mr. Prosper, thanks so much for standing in for me. I really appreciate it. And this was really an excellent class, really thorough, really explanatory. The explanation really drove the point home. So thank you very much, and we'll see you guys in the next class. That's all for me.